Okay, I'm just following the details in the chat there. Okay, so we have a lot to cover this morning, and specifically, I'm going to be providing a very brief sort of summary about what I see as sort of the major motivations for system science and agent-based modeling by extension in general, and then talking about features of agent-based modeling that the market is different from other system science modeling traditions. And we're going to be talking about some of the major motivations for use of agent-based modeling and system science approaches and dynamic modeling approaches more generally as part of this. But before I do that, I found that historically, for those coming to this for the first time, it can seem somewhat disconnected or somewhat dry. If you haven't seen models before in action, it all just sounds ethereal. So let's jump in to a little bit of hands-on work with a model. And I'm going to use that to illustrate some of the concepts that I'll then be gesturing at in my subsequent presentations. Now, in order to do this, we're going to make use of those resources that I had provided, which were pointed to by the wrong address there. So I think we'll just go ahead and use these. That particular model should be there, and we'll go with that, and I'll get you the updated address after the break. Okay, so first of all, we're going to call up AnyLogic. Now, AnyLogic comes in a number of versions. Nothing in this bootcamp requires more than AnyLogic PLE, the Personal Learning Edition of AnyLogic. I had suggested in some of the slides where that could be downloaded, but I'll just point out, if you go to anylogic.com, and I think it's at download or downloads here. No, downloads is my recollection. You can get this Personal Learning Edition here. So if you don't have it and you're not in front of one of the computers, you can download it, and there's no cost associated with that, and follow along. Okay, so I'm going to call up AnyLogic right now, and maybe I'll do so from the start so I can experience it in the same way that you will. So I'm going to go here and go to AnyLogic. I happen to be running 8.7.12. AnyLogic is actually regrettably persnickety about the minor versions associated with things. And so if any of you encounter problems opening any of the models, let us know, and we will render them in a fashion that is fit for your version of AnyLogic. Okay, so I've just called it up, and chances are, if you're calling it up for the first time, you will see a screen like this, which provides sort of a set of resources for getting going in AnyLogic. This is worth exploring at some other time. I will particularly note these example models and so on, but none of those resources are ones we're going to tap right now. So I'm actually going to go minimize using this button here, the screen. Yes, Larissa. Okay. Okay. So yes, it's probably because I neglected my instructorly duty of sharing my screen. I think that should be now showing. Okay. Thank you. Thank you very much. Much appreciated. And once again, the chat window has disappeared. Okay, there we go. Hey, thank you. Thank you, Sarah. Okay. So I've just closed that initial screen in AnyLogic, and we're left with a blank slate, as it were. If you've used AnyLogic before, you may see some projects here. But what we're going to do is to download a model to open in this, okay? It's waiting for us to tell it what model to open. And in order to get said model, we're going to need to use this link up here. Now, for those online, that link will be typed by a trusty TA into the chat, even as I speak, okay? So the top link there, stalwart TAs. I'm going to go into here, and I will enter that just to give the same experience. Tiny URL, and it's ABM Bootcamp 2022 materials. Not so tiny a URL, but what it lacks in conciseness, it gains in explanatory value. Okay, so there we are. And here we see an earlier rendition of this that is sadly redirected from it. Okay, so we're going to go into example models here, and we're going to go into AnyLogic 8 in model, and we're going to go down to a model which is called GIS Food and PA Environment V5 underbar AnyLogic 8. And what it lacks in brevity, it makes up for an explanatory value. So this is going to be a model that's going to be geographic, and it's going to have food and physical activity. And wouldn't you know, it's built for AnyLogic 8. Okay. So we're going to click on this, and we're going to then download said model. So by clicking on it, I'm going to go into this folder, and I'll right click on it and say download. Now, and some browsers, depending on whether you're using Safari or Edge or Chrome or Firefox, you may encounter no ability to download directly, in which case, if you open it, you will see a most unpleasant sight, but there should be a download button up there to the right, by which you can download it. Just, you don't have to feast your eyes on this, the stuff that's before you. Okay, so hopefully you should be able to get those downloaded. Is anyone having trouble getting them downloaded? Okay, TAs, could someone, okay, we have two people who need help here. So TAs, deploy, Marshall and deploy. Okay, we had one at the end there and one over there. Okay, who else needs help? Who else needs help? Okay, okay, anyone online needs help? TAs monitor the online environment. Okay. So we first had to download that model. We're going to be going through this many times from that set of models. And there's some help needed online. Awesome. Okay. Great. Great. So the raised hand. Okay. Great. Okay. So are we good to go forward over there? Okay. Okay. So okay, you're working with him? Okay, awesome. Okay, so what we're going to do here is we're going to open said model. So we'll do file open, and we're going to go find that model that we downloaded. I'm going to go through this in a leisurely way while people catch up, okay? So again, in AnyLogic, we're getting to this thing. If you had that initial screen, you press this to minimize it. You do file open and go and find that file that we downloaded. Up here, say in the downloads area, you'll open it. Okay. Okay, so it should be able to load in there. And once loaded in, it will be up in the upper left here. And my computer is taking a while, which is not bad. Okay. Okay, how's it going online? Okay. Oh, yeah, there are plugs in the front of each of these stations. So I should have mentioned that for those who have laptops, in the front of each of these stations, basically, not so far from where each of you are sitting, there are plugs you can plug laptops into. Anyone would be so desirous. Okay. So Nastaran, are we still working on it? Okay. Okay. So when you open this model, it will appear we did file open, and we selected the model that we downloaded wherever it lives on your computer. And it should open it up in this projects window. Okay. And what you'll notice is that this model consists of many constituent parts. You'll notice there's a reference to a person, to supermarkets, convenience stores, homes, parks, and a bunch of other components. We're going to go and we're going to double click on person here, which will be the focal point of our attention. And what we're going to see is that this model offers a sort of stylized depiction of processes in the world as they relate to weight and someone's weight dynamics. So you could see their weight in kilograms is being maintained here, with energy energy being taken in from food, and energy being expended both through basal energy metabolism as well as through physical activity. And although the details of the semiotics will remain to be elucidated, what you can see is that there's some indication, for example, that the distance to parks bears on physical activity expenditure of a person. You can also see their energy expenditure depends on their current weight. If someone's heavier, they tend to expend more weight in sort of their day-to-day physical activity, as well as their basal energy expenditure, their sort of energy expenditure absent physical activity. But you can see there's associated with this model some other components as well. For example, there's a state chart, which its name would suggest has to do with food procurement, and it posits some heading to either supermarkets or to convenience stores, for example, for food, which one might posit as offering different qualities of sustenance. And then below, there's some decision-making process maintained as to what they're eating on a day-to-day basis. So what we see here is, if you haven't encountered this, perhaps a bit puzzling. There's sort of a set of rules that are being put forward that posit behavior on the part of individuals as to how they make decisions about food, how they go engage in food procurement, food seeking, and characterization of how their weight might change over time. This, in short, is a model. It's a sort of simple mimic of a component of the world that simplifies the situation so we can reason about it, and uses a variety of languages, the languages of state charts, which will play a big role in this bootcamp, the languages of stock and flows, which will play a supporting role, and languages of action charts to diagram decision-making. Those are all woven into kind of this theory of how people's behavior and weight evolves out there in the world. So this is the theory for a particular individual as captured by this model. It posits that theory in a quite detailed way according to these different languages that we'll be exploring in the bootcamp. But this individual is not a solitude. And if we go up to Maine, if we go down Maine, as we'd say in New England, you can go and see that there's a broader environment being put forth within this model. And the environment has what by appearances would be a some sort of physical layout with certain resources, which I'll just mention are homes and supermarkets and parks laid out in some sort of spatial environment. And this environment, if we were to pour in it a little bit more, contains a set of food establishments, some of which are supermarkets, and some of which are more convenience stores. For example, the Meerkats convenience store. But you'll also notice that there's what will be a population of homes, a population of supermarkets, and a population of people there. So this is a model which posits a theory for individual evolution, frames that theory in languages that are quite precise, and situates those agents within a broader environment, an environment that is occupied by other people as well as other resources like parks, supermarkets, convenience stores. But this theory is not merely put forth in a modeling sort of way, in a way that lays forth our assumptions about what's going on in the world for critique. That's valuable. But it's also put forth in a precise enough way that we can say, well, what if this is the case? Go figure. In other words, what would the implications of this be for behavior over time? So we can run this model, and maybe we'll go click, for example, on baseline. We'll right-click on that and choose run. How did I do that? I went here to baseline and I chose run here, okay? And if we do this, we should come up with a window which will allow us to run this model. And that window is actually just behind here, but it should show something like this. And I'm going to press the run button here. And what you're going to see here is a situation where we have, okay, now this is an older version of the model, and I guess the geographic map needs to be updated here, but we have people moving around. The people are living in homes, and each person is depicted in this kind of, well, this is probably too old a reference for most of my TAs, but these are kind of Weeble-like individuals. They're shown as in these kind of icons as ellipses, and each of them is associated with a home and moves back and forth when engaged in food procurement. Each of those individuals has a certain state and is moving around. I'm going to use this pane over here on the right and open it up, and that will allow us to dive a bit deeper. So this pane here, we can, by opening it up, we can dive down, and I'm going to dive down to the population here. How did I do that? I open this window up here, and I went and I pulled this down and I scrolled down to the population, okay? And by so doing, I can start to see the situation particular individuals are in. So each of those Weeble-like ellipses that are moving around is actually a person. They have at a certain time a weight, and that weight is evolving over time according to this stock and flow diagram. That individual is engaging in periodic food seeking, which we'll see through this kind of successive pulsing of this food procurement state chart. You'll see sometimes, for example, they're heading to convenience stores, sometimes to supermarkets here and going shopping. And this individual is making choices according to additionally a set of rules as laid out by this decision-making flowchart. So, ladies and gentlemen, what we see here is not merely a model, it's a simulation model. It's a model where we can enact the rules in a way we could see their logical consequences. And according to that, we in accordance with that, we see a variety of scenarios. These scenarios differ, for example, the degree to which they involve walking going on to enhance physical activity. You can also see different population sizes. If we were to go run these, and I'm going to go, for example, run this medium population one, what we will see here is that same model, but I'm going to speed it up. So as I run it, I will put it on the fastest possible mode. That's this one here. And what we're going to see is people moving around at rates that are much, much faster. And I'd like to take this model and click on it and pull downwards. And one thing that you'll start to notice is that above this model, there are a set of graphs here. And these graphs involve characterization of a bunch of relationships within this population, which are being deduced over time. So what we're going to do is see, as this model plays out, patterns that are emerging from it in terms of certain relationships statistically between some of the types of information being gathered from these agents. So, for example, in this plot here, shown most directly on this screen, we have a plot that shows on the x-axis the distance of a person to a given grocery store in meters, and on the y-axis their weight in kilograms. And we're looking to see if there might be some relationship between that grocery store distance on the one hand and their weight. There isn't an obvious relationship eked out. This lower graph shows on the x-axis the fraction of meals a given person eats at a convenience store, and on the y-axis their current weight in kilograms. And we notice that there would seem to be some association here between this propensity people get convenience stores on the one hand versus their weight. The more they're eating at a convenience store, the higher their weight will tend to be in this associational graph. We don't see a clear association here with grocery store distance and weight, and we could posit why that might be. And one thing we would find is that we could undertake experiments to probe deeper as to why that is. For example, we might change certain assumptions about the model and see if that relationship changes in a way that starts to bring out a relationship. We can eliminate, or we can place convenience stores at certain distances from a person and see if normalizing for that helps make a difference. Here we have another graph, grocery store convenience store distance ratio on the right, on the x-axis. So, for example, 4 would mean their distance to the nearest grocery store is 4 times as large as it is to the convenience store. 2 would mean their distance to the nearest grocery store is twice as far as it is to the nearest grocery store. To the nearest convenience store. So the further you go out on the x-axis, the further and further you have to go to a grocery store relative to a convenience store.
Professor Osgood?
Yes.
The people online are having difficulty hearing you when you're that far away.
Okay, thank you. I recognize it's due to the directionality. Thank you for pointing that out. So here, the further out along this axis you are, the further you have to go for a grocery store compared to a convenience store. 4 here would indicate you have to go 4 times as far to get to your nearest nearest grocery store as you do to your nearest convenience store. 2 would mean, by contrast, you only have to go twice the distance to a convenience store in order to get to a grocery store. So the further out you go here, you have to really work to get to a grocery store, harder and harder and harder. And not surprisingly, people who live further from a grocery store relative to the nearest convenience store will tend to have what in terms of their weight? Does anyone want to say? What is this suggesting? What is this graph showing? Further, they have to go to a grocery store relative to a convenience store. What does that mean for their weight? Yeah, it tends to be higher. It tends to be higher. Now, these are associational relationships, and we could look at others here as well. But at the end of the day, the important point here is that we have a generative model. We have a model that posits some theory here that puts forth an explicit theory in a precise enough form that we can run it out and ask what its implications would be over time and over space, in fact, in this case. And by so doing, we can then compare those sort of empirical data, which we observe from the model, for example, against corresponding empirical data from the world, to the degree that we had any larger studies of walkability and environments, looking at the food environment as well, perhaps, and where we might be able to collect actual empirical data, we could scrutinize the model's predictions for what this association should be against what's observed from the world. A model depicted in this way, with this sort of theory of the world, gives rise to, generates certain implications for what we would expect to see along different variables that we can cross-check against observations from the world. Although we depict the behavior of agents and the decision-making of agents, the weight evolution of agents, we can aggregate those up to see patterns for the population as a whole, either summarizing each individual as a data point or conversely, taking averages across the population. So this is an agent-based model. It's enacted theory that's characterized at an individual level, at a level precise enough to be run, where we can then see the system-wide implications of that theory over time, and in fact, over space, as you will see here. So that's just a little bit of a glimpse of an agent-based model. This is designed to get you thinking about a concrete model as I go into some conceptual material here, to give you a point of reference for, some of the concepts that I'll be speaking about, concepts involving emergence, concepts involving a theory as captured in the model, concepts involving the implications of that theory over time or in terms of associations, et cetera. Okay, so with that having been run, I'm going to dive now into some slides that will try to take this buzzing, blooming confusion that we've been exposed to and try to explicate broader implications from it. Try to kind of play out what its implications are for how we conduct science and for us as health scientists, how we pursue research questions there. So I'm going to stop